In previous lecture, we discussed about the example of first use of dimension, conversion of unit from one system into another. Now we discuss about the example of second use. Example of second use of dimension. Second use to check up the correctness of any physical formula. Check up the correctness of following physical formula. Check up the correctness of following physical formula. First, V equal to U plus AT. Here U represents initial velocity and V represents final velocity. The velocity having the same dimensional formula, where U and V, velocity, A acceleration, and T time. In second we have to check LHS and RHS value of dimension. V, the dimension of V is LT minus 1. RHS, U plus AT. U LT minus 1, A LT minus 2, T LT minus 1 plus LT minus 1, 2 LT minus 1. Digit is dimensionless, therefore we leave 2 and finally we have LT minus 1. Therefore LHS equal to RHS. That is the formula V equal to U plus AT is dimensionally correct. Dimensionally correct. It is remembered that if a formula is dimensionally correct, it is not necessary that it is mathematically correct. For example, if we use the second use example, S equal to second equation of motion, S equal to ut plus half at square. This formula is correct. If we put the value of this digit in place of half as 1 by 8, then the LHS and the RHS of both sides are same. That is, this formula, although correct, if the numerical value is replaced by 1 by 8. But this formula is mathematically wrong. Therefore, it is not necessary that if a formula is dimensionally correct, then it is mathematically correct. LHS, S, the value of S, dimension of S is L, RHS, ut plus half at square. U LT minus 1 into T, हाफ को छोड़ देंगे. A dimension of A is LT minus 2, T2, L T power minus 1 plus 1, that is T to the power 0, T0 power is 1, L, L, finally 2L, and this 2 is less than RHS is equal to LHS. Therefore, LHS equal to RHS. Third, V square equal to U square plus 2AS. LHS V square LT minus 1 का square gives L2 T to the power minus 2. Now the dimension of RHS U square plus 2AS U LT minus 2 का square plus A LT minus 2 into L square T to the power minus LT power 1 T to the power minus 2 plus L2 T to the power minus 2 L2 T to the power minus 2. Avoiding the numerical value, then we get L2 T to the power minus 2. Therefore, LHS equal to RHS. LHS equal to RHS. Next example of second use. T equal to 2 pi T equal to 2 pi root under L by G, where T is time period, L length, and G acceleration due to gravity. LHS, dimension of LHS, that is T is capital T, RHS 2 pi root under L by G. 2 pi is numerical value and we can leave this digit. Dimension of L, dimension of G, LL cancel, root under T square, that is T, hence LHS equal to RHS. If a formula is dimensionally correct, then it is not necessary that it is mathematically correct. Next, small g equal to Gm by R square, where G gravitational constant, G represents gravitational constant, M mass of Earth, R radius of Earth. LHS G LT minus 2, RHS Gm by R square. G value of dimension of capital G is M L to the power 2 T to the power minus M minus 1 L3 T to the power minus 2 m minus 1 L3 t to the power minus 2 m by L2 cancel, L square cancel. Then after clearing the value we get Lt to the power minus 2. Therefore LHS equal to RHS. Hence this formula is dimensionally correct. Similarly, we can check all the physical formula either in 12th class or 11th class. We can check any physical formula by the method of dimensional analysis, knowing the dimension of each physical quantity. Next, V equal to root under 2 gm by r. Here V is escape velocity, LHS. Therefore dimension of V is Lt minus 1. RHS root under 2 gm by r, root under 2 m to the power minus 1 L3 t to the power minus 2 m L. The remaining value is L2 t to the power minus 2 Lt minus 1 square. Therefore it is equal to Lt minus 2, or LHS equal to RHS. Next, V equal to root under 2 gr. LHS escape velocity. This is formula of escape velocity. Lt minus 1. RHS 2 gr. 2 is digit. The dimension of G Lt minus 2 as Lt minus 1. LHS equal to RHS. Now the next example of second use, the velocity of sound. The velocity of sound is given by V equal to root under gamma p by rho. Next, V equal to root under gamma p by rho, where V equal to velocity of sound, gamma p pressure, rho density, and gamma, it is dimensionless constant, that is ratio of same physical quantity. It is ratio of two specific heats, Cp and Cv. It is dimensionless constant. Dimensionless constant. LHS V, dimension of V, velocity of sound is same as velocity. RHS gamma, dimensionless constant, dimension of pressure ml minus 1 t minus 2, rho dimension ml minus 3, cancel, L2 t to the power minus 2 L t to the power minus 1 square, L t to the power minus 1. The LHS equal to RHS. One more example for second use. If the wavelength, the de Broglie wavelength lambda equal to h by mv, where lambda is wavelength, h Planck constant, Planck constant, its dimension is ml to the power 2 t to the power minus 1, m mass, v velocity, LHS lambda, L RHS lambda by mv, it is equal to ml2 t minus 1, m lt minus 1, then the remaining L, hence LHS equal to RHS. Hence the formula lambda equal to h by mv is dimensionally correct. Now we come across the example of third use of dimension to establish any physical formula. To establish any physical formula. In this use, some one value of physical formula depends two or more value. Then we write the equation as for example of third use. Example of third use. The time period T of a simple pendulum, T of a simple pendulum depends upon length of pendulum L and acceleration due to gravity. Acceleration due to gravity G. Establish relationship among these quantity by the method of dimension. The time period T of a simple pendulum depends upon length of pendulum L and acceleration due to gravity G. In such type of question, one value T depends upon two or more. More value depends. In this question, T depends upon L and G. Assuming the power of L, X and G, Y. That is T proportional L to the power X and G to the power Y. Or T equal to K, L to the power X, G to the power Y. Where K is dimensionless constant. Where K is dimensionless constant. Writing dimension of each physical quantity